Oh, hello. Welcome back to the third video in equity valuation. So now we know basically from Finance 100, we've done all this. So um, to find intrinsic value, just like, as I explained in the previous video, we have four variants of the um, uh, intrinsic value model to find intrinsic values, and namely, all these models are called dividend discount model, and of course, dividend discount model comes from, right? It's actually a subset of DCF, or discounted cash flow model. Right? Now, the first model is the constant dividend model, or zero growth model, constant dividend or zero growth model, and they all come from the basically this one period, a single period valuation model, which is simply what holding period return, how we define the holding period return, right? But think about it. If we are solving this equation for, because this is a discounting, right? Discount model, right? Which is present value. So think about it. If we solve this for the numerator, in other words, the left-hand side will be expected dividend at time 1 plus expected price at time 1. Or actually, I would like to change the notation to let's skip doing this. But let me do this. I will change the notation to because if it is expected price, then that should be a rational price. And then the right-hand side, it will be simply V0 times 1 plus K, which is exactly, what does this, which is exactly what? One period compounding model. Isn't that right? One period compounding, finding the future value, right? But think about it. Suppose we don't have this term, right? If we don't have this term, and only if you have this term in the left-hand side, then it will be simply the growth right? That will be, if that's the case, this will be no different than growth rate, right? But the fact that this is not growth rate, but rather, required return means there's a difference between the required return and just the growth rate, because because the return or the yield always include not just the future value of the stock, but the incidental income or the investment income as incidental cash flow, right? Now, of course, to use, to derive constant dividend model, we will have to assume infinite horizon. For example, if we extend this one period model to time horizon h, right? And in that time horizon h, right? Actually, this term can be broken up into dividend at time h, and then 1 plus k. 1 plus k raised to h, and then plus, let's call this, a value of this time h, 1 plus k raised to h. Okay? And think about it. If time horizon h goes to infinity, right? If time horizon h goes to infinity, then that means, our assumption is for constant dividend model. And what would be an example of constant dividend? A stock that pays constant dividend. A perpetuity is a perfect example of constant dividend paying stock. A perpetuity is, paying, like annuity, paying constant dividend, but it goes on forever. Because it goes on forever, the time horizon, it is only natural that the time horizon will go to infinity. Now, here's the thing. And because everything, if it is perpetuity, there's no distinction between dividend 1, dividend 2, dividend 3, or dividend, in other words, they are all the same, right? Of course, you can still put the time subscript, but no matter what, dividend n, they are all the same. Okay. Dividend 1, dividend 1 is equal to dividend 2, which is equal to dividend 3, right? And it goes on forever. So which is also equal to dividend n, right? So there is no point in using time subscript because they are basically all d, right? The same dividend. Okay. Now let's think about another thing, right? This future value, right, at infinity. Future value at infinity, think about the future value at infinity. So let's say I mean, future value at infinity, right? And dividend at infinity, okay, we don't need any time subscript because it's always the same thing. Now let's think about it. What is going to be the value of the stock at infinity? Huh? Is it going to be an infinitely large number, or because it is infinity, it's going to be infinitely large number? Some people may say yes, but if you say yes, you're not really thinking deeply. Like, first of all, just because it's infinite future, the price of the stock won't grow to infinity. Why? It will still be a finite number. Finite number, right? Why? One good example, we just saw that, in the last week, August 31st, Apple and Tesla split, right? Tesla was almost 2,000 something. Apple was 1,000 something. They split. So they did, Tesla did 5-to-1 stock split. Apple did 4-to-1. Now, why did they do the stock split? I'm not going to go over this again. I believe I talked about this already. It's the liquidity and marketability. I mean, if the price is getting too high, it becomes more onerous to trade because you have to tie up your money into a small number of shares. It becomes less liquid and less marketable. So they split. So suppose in the infinite future, will Tesla be like $1 million, $2 million? No. If it is $1 million or $2 million, then it will be very hard to trade. And besides, you might say, 1 million years later, 2 million years later, I mean, if the company still exists, the company is still, around, wouldn't $1 million be nothing? In $1 million would be only worth $1,000 today. Or look, if that is the case, what does that mean? There's going to be a huge inflation. I mean, 1,000% inflation already, right? If it is. If it is, especially if $1 million is nothing like something like $100 today, then it's 10,000% inflation. Even million years later, if the inflation, 2% inflation is Federal Reserve's target. But let's just quickly do some calculation. But annually, 2%. It will be a huge number, but So if you just, raise 1.02, let's say every year, inflation is 2%, let's raise it to 1,000 years. Raise it to wait a minute, 1.02 raised to 1,000. And it's going to be huge, anyway. But, I mean, if inflation compounds for 1,000 years, it will be a huge, even 2% inflation. But again, the point is, they won't allow, if the economy is suffering from like, a 10,000% in inflation, it's gonna, there will be a revolution, right? The civilization will come to an end. Another factor that doesn't allow this to happen is the business cycle. So stock split is one reason this won't happen, right? In other words, value of the stock at infinity won't be an infinitely large number. It will be a finite number. Another one is the business cycle, right? Through boom and bust through business cycle. The stock price would go up and then burst, falls, and goes up again, burst, falls, So there is certain, because of this cyclical nature, the price will go up, but it won't go up like a straight line or exponentially, right? Now, anyway, think about it. If this is a finite number, right? Numerator is a finite number. What about the denominator? Denominator will be, I just did 1.02 raised to 1,000. It comes to a huge number. I mean, if this goes to infinity, this is going to be incredibly huge number. In other words, this thing, the denominator itself will become infinity. Okay, denominator by itself become an infinity. Now think about it. You're dividing a finite number by an infinitely large number. What's this going to be? It's going to be close to zero, right? You're dividing a finite number by an infinitely large number. This number will become not exactly zero, but close to zero. Okay, makes sense? Close to zero. So in other words, this term will fall, right? This term will fall, right? Because it's close to zero. It will fall out. We don't have to worry about the future value of the stock, right? So this becomes purely a model of dividends, right? Now we are discounting dividends infinitely. But then how does it suddenly turn into this? How does this suddenly turn into this? So they are all the same thing, right? So this involves, this requires an explanation using infinite geometric series. And although we did it in Finance 100, I don't think you can remember it. I don't think, and besides, even if you remember, you cannot derive it yourself. The point is, this is 300, Finance 300. You should be able to derive this formula, right? So let me insert Okay, to do that, I will have to let me insert a new slide. Okay. Let me, so first of all, yeah, let's do this one. V0, we know this one. Yeah. That's not very nice. It's not done neatly. You know, it's d over 1 plus k plus d over 1 plus k squared. And what's going to be next? D over 1 plus k to the third power, right? And it keeps on going. Let me just do one more. D over 1 plus k cubed, right? And then it keeps on going until, you know, we get to d over 1 plus k raised to infinity minus 3. Let's just do 2, infinity minus 2. And then plus d over 1 plus k raised to infinity minus infinity minus 1, and then plus d over 1 plus k raised to infinity. And let's call this equation 1. Let's call this equation 1, right? And then I will multiply 1 plus k to both sides, right? In other words, I will multiply one plus k to equation 1, and I'll call it equation 2. So equation 2 will be the first term will be simply d, because, you know, I'm multiplying 1 plus k on both sides, because if you multiply to the left-hand side, you must do the same thing to the right-hand side too. So everything here is multiplied by 1 plus k, then the numerator gets, you know, canceled out. So it becomes only 1 plus k d. The next one will become, it will lose one exponent, right? This will become 1 plus k. Okay, you get it? You get the idea? And this term will become d over 1 plus k squared. And something here, something which had, you know, 1 plus k to the fourth will be, you know, right, 1 plus k to the third, and then this term will become 1 plus k raised to infinity minus 3. Okay, and this term will become 1 plus k raised to infinity minus 2. And this one will become 1 plus k raised to infinity minus 1. But look, but the thing is, infinity by definition has no end. So actually, I will call this 2, equation 2. So equation 2 is simply, equation 1 times 1 plus k. Right? You get that? All right. And then I will, this is only a representation, but think about it. Because infinity doesn't have any end, it will keep going on and on and on, right? And then since this is a finite number anyway, at infinity, they will drop out. Now, what I'm going to do is now I will subtract equation 1 from equation 2, okay? Then what's going to happen? In the left-hand side, it will be V0 1 plus R, then minus V0, right? 1 plus K minus V0. And we know it can be rewritten as V0. V0. You can factor out V0, then it becomes one plus K I minus 1, right? Of course, they cancel out, right? And then on the left-hand side, the only thing that remains will be D. And that will be Y, because you're subtracting 1 from 2, equation 1 from 2. That means, all of the equation 1 will change sign. It will be negative, right? So this, you're subtracting, because, so then these two will cancel out. These two will cancel out. These two will cancel out. Something here will cancel out with this. So these two will cancel out. These two will cancel out. And then eventually, we will have also, think about it, at infinity, this will become also 0, right? And also, this will also, follow infinity, just by one term, right? But they all cancel out. So the right-hand side will all cancel out, and so we have, except for D remains. So if we rewrite it, right, this becomes V0K equals D. And if you solving it for V0, what does it become? D over K. Okay? You see, this is how that formula of zero growth model is derived. Okay? And it's called, this process is called infinite geometric series, and voila. Okay? So it's not just, memorizing, and from Finance 100, I've taught you how these formulas are derived. And I didn't require in Finance 100, I didn't require you to be able to derive. At least, I only expected that you would understand the process. But in 300, you should be able to derive it on your own. Okay. Now, I will call this. Okay, I will add title later. I will call this derivations of zero growth model or something. But the time is up, so I will have to cut the video and see you in the next video. Thank you for watching, and I'll see you guys in the next video.